Software engineering has moved from a model of human execution to one of orchestrated agents. The primary constraint is no longer developer hours, but the computational power required to drive these systems. For 30 years, IT budgets were built on simple geometry. You took your fixed headcount, multiplied it by a fixed monthly cost per user, and produced a predictable annual forecast. When early AI coding assistants arrived, they appeared to fit this established pattern. At $10 to $20 a month, they looked like standard software licenses to be managed alongside a standard Office suite. This chart exposes the resulting budgeting mismatch. Organizations initially allocated a fixed seat cost, assuming that AI expenses would remain flat and predictable as adoption grew. However, a seat license only grants access to the interface. The actual work is performed by tokens. Without an allocated token budget, the agent has no capacity to execute tasks. Every time an agent plans a task, writes code, or verifies a test, it consumes tokens. This represents computational inference, a variable cost that scales directly with the volume of work produced, rather than the number of developers employed. Treating a dynamic, resource-intensive engine like a static piece of office furniture ensures enterprise budgets are caught unprepared as usage scales. The financial data confirms this growing disconnect. Average enterprise AI inference spending surged 40-fold between 2024 and 2026. This explosion in total spending occurred even as the individual cost per token dropped by a factor of 280, proving that efficiency gains are being outpaced by massive increases in usage. This is driven by agentic workflows. A single developer initiating a plan, execute, verify loop triggers thousands of automated, recursive API calls that are largely invisible to traditional cost tracking. This trend follows a specific maturity curve toward a critical threshold. During pilot and adoption phases, token burn is masked by soft caps, making budgets appear sufficient. The crisis arrives at scale. Moving to fully agentic pipelines causes a breach of the static budget. The resulting six-figure API invoices demonstrate that traditional fixed-cost budgeting frameworks have no mechanism to manage or account for variable AI output. Faced with these unexpected costs, most organizations react by freezing deployments or diverting funds from core infrastructure to pay the bill. On the left, we see the most common response, a central ICT budget that attempts to control costs by distributing strict top-down monthly quotas to every developer. This central pool model cannot distinguish between value and waste. A central administrator has no way to know if tokens were spent on a critical revenue-facing feature or a low-priority internal experiment. When a developer running a complex system refactoring hits their limit in a single afternoon, the central model forces them to stop. This creates a culture of rationing. Developers become hesitant to use agentic tools, reverting to manual coding to preserve their tokens, which effectively cancels out the productivity gains the tools were meant to provide. Attempting to ration a variable input like tokens doesn't stabilize the budget. It strangles the engineering output that justifies the investment in the first place. The tech industry solved this exact problem during the cloud migration of the 2010s. Organizations learned that central IT cannot effectively manage elastic server costs that fluctuate with demand. The right side illustrates the shift to AI FinOps, where financial accountability is moved away from central IT and placed directly within independent business units. In this model, tokens are managed as a direct variable input. Their cost is justified by the specific business value the team produces. You can see how budgets align with objectives. A payments team shipping a critical product receives 90% fuel capacity, while a team on routine maintenance operates with a more constrained allocation. This allows teams to make informed trade-offs. An engineering lead can decide to spend more on tokens to accelerate a deadline, effectively substituting computational spend for additional human hours. Financial control is maintained by linking spending to results, converting a blind expense into a transparent investment in delivery speed. Moving to a business unit fuel economy requires a data-driven framework to ensure that every dollar spent on tokens is visible and accountable. It begins with attribution. Every API call must be tagged and mapped back to the specific team and project, providing a clear audit trail for every token consumed. This granularity allows finance leaders to answer a critical question: what specific features or products were billed for the price of that invoice? The next step is automation. Organizations deploy real-time monitoring to track spend against forecasts, replacing slow, manual reporting with instant visibility. Instead of hard caps that break the workflow, platforms use soft limits. When a team hits 80% of their budget, they are alerted to optimize their usage without having their work halted mid-task. Providing engineers with real-time feedback on their token burn encourages natural optimization. The system becomes self-regulating without the need for central bureaucracy. But why should an organization endure the friction of restructuring its entire financial model just to fund token consumption? The answer lies in a staggering 78% reduction in the cost of engineering output for those who successfully manage the transition. Look at the traditional team. The $900,000 annual cost is dominated by salary and massive coordination overhead. Contrast this with the conductor model on the right. A single senior engineer with agentic tools costs $200,000 total, including $50,000 for tokens. These savings are achieved by eliminating the asynchronous delays, stand-ups, and manual handoffs that consume the majority of a traditional team's time. While a traditional pull request costs roughly $150 in human effort, an AI-augmented request costs approximately $50. By funding tokens, the organization is paying to bypass the coordination delays inherent in human-only structures, shifting the investment from synchronization to immediate execution. This cost advantage creates a gap in market velocity. Organizations that ration tokens ship and learn slower than those running at full capacity. When a competitor can afford 3 times as many product iterations for the same budget, they identify winning features faster. Over time, this iteration delta becomes a lead that slower organizations cannot close. Those who deliberately fund the token economy unlock a velocity multiplier. They use agents to handle the volume of code, while humans focus on the high-level intent, accelerating the entire delivery pipeline. As the summary notes, tokens represent the fundamental electricity for modern engineering. Organizations that integrate this cost into their delivery model maintain a continuous shipping advantage. The choice is clear. Treat AI as a fixed administrative seat and risk falling behind, or treat it as raw computational fuel and gain the speed necessary to lead the market.